All right, here we go. So are shared coordinates real world coordinates? I think they are. When I started getting ready for this presentation, I wasn't sure what Autodesk or Revit thought, but by the end of it, I am sure that Autodesk agrees that shared coordinates are real world coordinates. So these are the learning objectives for this whole session. Working with survey files from civil engineers to set the Revit projects to real world coordinates. And part of that involves understanding the formatting of DWG files from Civil 3D, understanding the positioning points in Revit, which include the Revit internal origin, the project base point, and the survey point, and establishing a workflow that can be applied to all projects to simplify and provide clarity on this complicated process. Understanding and avoiding common problems before they become big issues. And also, I'll just say, interrupt me if you have any questions, because I think it'll help answer them right away. So just let me know. Okay. All right, so unfortunately, even though this is the Revit user group, we have to start out talking about AutoCAD. Because the problem is intelligent objects in DWG files that are generated from Civil 3D. The problem is that the DWG generated from Civil 3D has these special elements that are only editable or they can only be created by Civil 3D, and they are often called intelligent objects. And what happens is when we open them in regular AutoCAD doesn't understand those elements, and so we get this proxy graphic warning. And for me, that proxy graphic warning is a problem that, it's telling me that there's something wrong and we shouldn't proceed. And I'm going to explain why, as far as our process with Revit anyway. It's because Revit doesn't understand those elements either. And so when you bring a DWG file into Revit that has those elements, it causes problems. Unfortunately, Revit will still let you link in a Civil 3D file that has those intelligent objects. And you won't really know until you end up having problems like this, where your view gets all like half wireframe, half, like just your 3D views get kind of corrupted like this. So the other problem is that they tend to be very, very large. Down at the bottom, you can see the top file originally came from the civil engineer directly. This is the file that is their working file that they were working on in Civil 3D, and it was 37,000 kilobytes. After we did the export process that I'm going to explain in the next step, it got significantly smaller, which you can see in the second line down, 2,000 kilobytes. So there have been quite a few common misconceptions about what the problem is with these files that come from Civil 3D. And it's not that they're far away from the from the AutoCAD origin, 00. That's not the problem. The problem, we actually want them to be far away because that's how we get the real world coordinates. The civil engineer sets them up, or they do their AutoCAD drawing setup, so they're using the real world mapping system, and that involves having all of their line work be really far away from 00. The problem is also not that it's in 3D, even though it looks like a mess, like you can see on the screen here. I don't think I've ever seen a file from Civil 3D not look like a mess like this, but the line down at the bottom is AutoCAD 0, and then everything up above is the actual contour lines at the correct Z elevation in AutoCAD, which is the sea level, the real sea level height for the project. We actually want that because that's also how we get the coordinates, the real world coordinates, and is how we generate the topography element in Revit. So what's the solution? The solution is export to AutoCAD. It's a command that they can type in Civil 3D, just right in the command line. They type export to AutoCAD. And what that command does is it creates a new DWG file that has converted all of those special Civil 3D intelligent objects into AutoCAD plain old AutoCAD elements, lines, arcs, and circles. If they don't want to type the command, it's actually also an option on their file pull-down menu. They can go to export to AutoCAD, and then they can specify what year format for AutoCAD. And then after you do that, the resulting DWG file is significantly smaller, which helps us in Revit, but it's still going to be far away from 0, 0. That's okay. And it's still going to be 3D, which is great because we need that. And look at the file size. It's 2,000 kilobytes. So all that being said, there have been some other problems that we have encountered with AutoCAD and this whole issue of positioning. And one of them is with the landscape architects, because they will usually start their file by linking in the civil engineer's civil survey, and they will start drawing all of their line work and everything in the exact same place, far away from 0, 0, in the same spot that the civil engineer kind of started. And what they often will do is in AutoCAD, you have the ability to move the UCS, and you can set it to a specific point. It's almost like the project-based point in Revit. So what I've seen some landscape architects do is move that UCS to a location on the site so that it's easier for them to work within the site when they're not so far away from 0, 0. That is good for them, but it creates a problem for us when we try to link their drawing for the landscape design into our Revit model, because even though it is still kind of in the same coordinate system, it actually messes up the coordinates when you try to link into Revit if you choose the shared coordinate, position by shared coordinates, which is actually the real world coordinates, and it won't work. So the solution is to open up that DWG file from the landscape architect and move the UCS. So the command you can see down at the bottom of the screen is you type UCS and then type move. And then you can type the new origin point that you want the UCS to be moved to, which is 0, 0, 0. Hit enter, it moves the UCS, and you hit save, and that's all you have to do. And then when you link that DWG file back into Revit using the shared coordinate positioning, it'll go in the right spot. So I thought we could have a little bit of fun. This is where the fun part starts that I promised. Do you guys remember those Choose Your Own Adventure books? Hopefully you all had the opportunity to enjoy those as kids, but I thought we could do a little Choose Your Own Adventure with like a game with our civil 3D file that we received from an engineer. So you receive a survey DWG file from a civil engineer who's working in Civil 3D. Taking note of the file size, you discover that it's quite large. Who knows if this will cause a problem? So you have a choice. You can decide to open it in AutoCAD, or you can decide to link it into Revit anyway. We're going to open it in AutoCAD. So we decided to open it in AutoCAD. Good choice. Lo and behold, the proxy graphics warning pops up. So we have another choice. We can either ask the civil engineer to export to AutoCAD, or we can decide to link it into Revit. So we're going to decide to ask the civil engineer to export to AutoCAD. So after you requested that the civil engineer sends you a file created by using export to AutoCAD command, you receive a new file from them. If you open the file in AutoCAD and you still get the proxy graphics warning, turn to page 9. If the file is significantly smaller than the first file they sent, and when you open it in AutoCAD, you don't get the proxy graphics warning, turn to page 14. Well, unfortunately, we opened it and we still got the proxy graphics warning. And I'm not kidding, this happens all the time. So apparently, something got mixed up in the translation. They didn't understand what we meant when we asked them to export to AutoCAD. So what you can do at this point is you can send them this link, which is the link to the Autodesk knowledge base article about using export to AutoCAD. So we send that to them. They send us another DWG file. Thankfully, this time, It is significantly smaller than the first. We don't get the proxy graphics warning. So now we're finally ready to talk about Revit. Don't get too excited though, because we got to do some planning first. All right, so our planning is we have to talk about the points in Revit that we can use to position the building. So the first point is the survey point. The survey point is basically the coordinate system that provides real world context for the building model. So it's intended to describe the locations on the surface of the Earth. This is synonymous with basically the system that the civil engineers work with. So I just took the screenshot from the Autodesk help article, which the link is there on the left, and it is just showing what other software applications call this point. You know, there's a lot of other terms that are synonymous with survey point. And also notice that it's a triangle icon. So then the project-based point is for the project coordinate system. So it describes the locations relative to the building model itself. And that is more synonymous with like the UCS in AutoCAD, which is what I was mentioning earlier. Notice it's a circle icon. And then the third point is the Revit internal origin. So the Revit internal origin is the internal coordinate system within Revit. And it's the basis for positioning all elements in the model, even the survey point and the project base point. And it never moves and it never changes. So using it or from it as like an anchor, you can establish the project coordinate system and the survey coordinate system. So the internal origin has also been referred to as the startup location. And when you start a new model from the template that comes out of the box, and hopefully the template from your office is the same, the survey point and the project base point are both located at the Revit internal origin. And in Revit 2020 and versions since then, they have added an icon for the Revit internal origin, which you can turn on in the same way that you turn on the project base point and the survey point. So when you go to your visibility graphic overrides under the site category, we now have an additional subcategory called internal origin, in addition to project base point and survey point, so that you can turn those all on in any view where you want to see them. So part of this planning process, I'm going to spell out some recommendations that I have based on having done this on many, many projects and having spent countless hours troubleshooting problems that usually occur when the points are in 3 different locations. And so what I've found is that I recommend keeping all 3 points in the same location at that original origin starting position. And I think what may be confusing is like, well, how do you set them to be real world coordinates then? Well, you can actually keep the location of the points in that same spot at the internal origin, but just set the real world coordinates of that point, but they still say located at the origin. And all 3 points, okay, so we'll move on to that later, but so let's just say we've established that we want to keep all 3 points in the same location. But still, we also need to think about where that point should be relative to the building itself, where you start to model the elements of the building. And most of the time, we start modeling and we don't even think about where the project base point is or where the origin is. Half the time, we don't even see it in the view where we start modeling, right? So you just start modeling walls, and then all of a sudden, there's this very important consideration about where that origin point is relative to the model that, you know, it's too late by that point when we just start modeling without thinking about it. So if that's what happened, it's okay. You just leave it the way it is. And I'll explain that a little bit later, but that is still better than trying to move anything. Okay, so now if you think about when you're linking one Revit file into another Revit file, there are 4 different positioning options. There's the center to center, origin to origin, shared coordinates, project base point to project base point. Because we have those different options, if they're all in the same place, it really simplifies the process because we don't have as many options. We don't have as many places to make mistakes. So down here, of those 4 options, it's showing that if between a structural model and an architectural model, if the project base point, survey point, and internal origin are all 3 in the same location relative to the building geometry, when you go to link them into one another, you can either choose origin to origin, shared coordinates, or project base point, and they're all going to line up correctly. The only one that won't work is center to center. If they were in different locations, though, as shown here in this screenshot, it gets a lot more complicated. It's not the end of the world. It doesn't mean that we can't function, but it just makes it more complicated, and it means the project team is going to have to talk to each other more. So in this example, we have one file here and one file here, and it shows that the survey point is in the same location in both files. So that method of using shared coordinates would be okay. And that is because the shared coordinate or the survey point coordinates are actually set the same. And the project base point is not in the same location in both files. So if we were to link project base point to project base point, that would not work. But the internal origin is in the same location for both buildings. So you could link origin to origin, and that would work. So I hope that this shows you how, because there are so many different points, well, basically 3, you can have different combinations of them being located in different spots, and that just makes things really complicated. Okay, so hopefully at this point we've established that we want to have all the points in the same location, and we want them to be at a known location at the corner of the building. And we also recommend making a completely separate Revit model for the site. And that Revit model is where the civil survey would be linked into Revit, and it's where the topography and any other site elements would be modeled in Revit. And then that file would be linked into the architectural model of the building. So we've created a new Revit file for the site. And now what we need to do is open up a site plan view, because you should always link your civil survey into a site plan view. And when we're linking it in, we're going to use the option of center to center, because we're going to have to move it anyway. So it doesn't really matter. And if we use center to center, hopefully we'll be able to find it. Sometimes I've found when you first link in a DWG file, it doesn't appear on the screen right away, and it takes some hunting to find, you know, is it just really far away, or is it at a high or low elevation and out of your view range? Sometimes it can be hard to find. But because we usually do start modeling in Revit before we link in the civil survey, because sometimes we don't even have a civil survey when we first start a project, hopefully we have established a corner of the building at the Revit internal origin and the survey point project base point. And hopefully we've kept the survey point and project base point in that location. One of the rules that I make for people, if they're starting a new project and we don't have the civil survey yet, is that's okay. Just don't move the project base point and don't move the survey point. Just leave all of them set to 0, 0, 0, and we will set it when we do get the survey. Because as long as we model everything, as long as all the building elements are modeled so that that one corner of the building that we establish at the Revit internal origin, that's like the anchor. And as long as we don't change that, we can work that way for quite a while. And then when we do get the civil survey, then we can set the coordinates of that point to the real world coordinates at any point in the project. What makes it challenging and difficult is if people try to set it one way ahead of time, like in a conceptual or a schematic way without having the actual information. What's very difficult is trying to change it after it's already been set up. If it's been set up in a way that was not 100% accurate, and then we have to change it after, that is very difficult. So it's better to just keep it at 0 until you know you have the civil survey that is not going to be changing. Okay, so the first step, once you've linked in that civil survey, is to move and rotate the DWG link to the position of the model. When you are choosing the base point for the move, use the same point in the DWG link as the location of the project base point in the architecture model. So that same point that we saw in the previous screenshot, that's the point that we need to snap to as our base point for moving the CAD file so that it will line up with the building when we link the site file into the building, to the architecture model. And after we move the CAD link, then we have to rotate it into a Plan North. Plan North, Project North orientation. Can you guys see the video okay?
Yeah.
Okay, good. Okay, so the CAD file is in the same position as the building outline of the CAD is the same orientation, location, and rotation as the architecture model relative to the internal origin of Revit, which is also the same as the project base point and the survey point. Okay. So we positioned it correctly in plan, but we also need to move it in elevation. So the DWG file needs to be moved down, whatever the finished floor elevation is of the level that the CAD link was placed on. So we were in the site plan view when we linked in the CAD file. Whatever level that site plan view is associated with is where AutoCAD 0 will be placed. Because the AutoCAD file has all of those contour lines drawn at the correct sea level elevation, if you know what the finished floor elevation is of whatever you want level 1 to be, then that's the distance you need to move the CAD file down. The next step in the process is to unclip the survey point and then acquire coordinates, which is always my favorite part. So I filter select to make sure that we get the survey point, and you unclip it and then go to acquire coordinates, select the CAD file, and it acquires the coordinates from the CAD file. So we also filter select the survey point again and just look at those coordinates. You can see that they changed and they now have been updated with the real world coordinates. And same thing in elevation, we check it again, filter select the survey point, verify that the coordinates are correct, and then you clip the survey point. And then select the survey point, project base point again, push pin them so they don't move, select the CAD link and push pin the CAD link. Once we get this all set up correctly, I like to push pin everything so that we don't have to worry about it getting moved accidentally. So the end result is that the site should be aligning with the building, and the survey point and the project base point should be set to the real world coordinates, but they're still at the Revit internal origin. So you can see these screenshots. We have the plan view, the internal origin, survey point, project base point are still at that location, but their coordinates now read the real world coordinates. Also have the north rotation as well. And in elevation, the project base point and survey point are at level 1, or whatever level you establish you want to be basically your project 0. Okay, so we just set it up for the site file, but now we have to go through that same process again for any other Revit files that are part of this project that all get linked together. Because in order to be able to use the positioning of shared coordinates, all of the files linked into one another have to be using the same world coordinate system. So in order to do that, all of those files, and this is where I was thinking, Sal, this might be helpful to you, because if you bring in the same civil survey that the architects did, and you go through the same workflow in the structural file as the architects do in the architecture file, then if the survey point, project base point are at the Revit internal origin, and then they're set to the real world coordinates, you'll be able to link in the architecture model, and they will be able to link in the structural model using either origin to origin, shared coordinates, or project base point, and all of them will work. So that's sort of like the perfect world scenario that I just described, where all the points are located, in the same spot, because that really simplifies things. But most of the time, that's not really that's not reality. So in the next couple of slides, I'm going to go through some examples of when we have had situations that aren't this sort of perfect world situation and how we've addressed them. But the one thing I did want to mention is that the process will be the same that you have to go through with all the files. As far as you could either link in the DWG survey and get it positioned correctly, X and Y position, rotation, and then also an elevation, and then acquire coordinates, or you could get it from the Revit model. So in our architecture model, we could link in that site file that we created instead of the DWG file and acquire coordinates from that. So Sal, if you didn't have the civil survey, you could link in the architecture model or the architecture site model and acquire coordinates from that. So it'll work. You just have to acquire the coordinates from any file that has them set.
Yeah, that's our typical workflow, is to, whenever we create a project from an architectural model, we acquire the coordinates as a start, so we're on the same page.
That's good if they have them set up, but
yes, but usually when we come in, they're usually set up at that point.
Okay, that's good. But I will say that's probably always a good thing to talk about at the BIM kickoff meeting, if every discipline is involved, and you can kind of have the civil engineer in the room and the structural and MEP and everybody in the room and just say, okay, is the civil survey set in stone? It's not going to change. Okay, good. We'll get our coordinates set up. If you set them up in the architecture model and then everybody else acquires from that, then that's good too. Okay, so I kind of mentioned before that it's very difficult to reacquire coordinates after it's already been done once, short of like just doing an undo right after you do it. Like if you acquire coordinates and then you realize right away that you missed a step, you can undo and work backwards. But if time has passed and you've done other work, don't attempt to acquire coordinates again. In this example, we didn't unclip the survey point. And so this is showing what happens if you don't unclip the survey point first. When you go through the process of acquiring coordinates and you select the CAD file, it looks like the survey point moved really far away. What it did is it just stayed at 0, 0. And so that's because it was clipped. So when it's unclipped, it allows it to stay in the position it was in when you acquire coordinates. So in this case, the fix or the solution is to unclip the survey point, move it back to the Revit internal origin location, and then reclip it. And then its coordinates will update when you do that because it's unclipped. And unfortunately, you also have to move it in elevation when that happens. So it's nice to remember to unclip the survey point before acquiring coordinates. but it's not the end of the world if you don't. It just means you have to go through these 2 steps of moving it in plan and then also moving it in elevation back to the Revit internal origin, and then re-clipping it and then re-push pinning it.
I have a question, and it might be like from a while back, but can you say again why, like how to start modeling correctly, like in the correct place before the survey is even involved at all? Because like what did you mean by that, and how did you do that in this example that you were using?
I just started with the corner of a building so literally the intersection of 2 exterior walls and where that corner falls. And it's not critical, but it just helps. And I'm going to show a few slides ahead what the process is if the survey point is not, or if the building model was not located at that corner. The big difference is that if you put the corner of your building at the origin, when you go to set up the separate site file in Revit and you link in the AutoCAD file, you'll be able to find the building footprint in the civil survey and find that same corner and put it at the origin. The problem is if your architecture model is over here and you have no way of knowing how to locate that civil survey in the same location as your building relative to the origin. So it just makes the process a little bit more complicated, but I will show how to.
So you're just modeling that intersection at the Revit internal origin point is all?
Yeah, the intersection of the corner of the building. And if it's one that you know isn't going to change, then that would be a good one to choose to put at that corner. Or it just can act like the anchor for the project. And then anything that moves or stretches about the project that one point would be constant and not change, and everything else would change around that. Does that help?
Yeah, yes, thank you.
Okay, good. So we've also encountered problems in the past where the DWG link rotates back to its original position so we went through this whole setup process and then we reloaded the link. And what happens is it moves. And we had this problem happen on quite a few projects before we finally found the Autodesk knowledge article that is a link here on the left. And then in the next slide, I'll tell you what the solution is. But basically just in the video, it shows what happens when you reload the link. Even though we had it positioned correctly, watch it move. So it looks like it's moving, but I think what it's actually doing is rotating. And I think it has to do with the difference between the view that you link it into initially, that site plan view. If it's set to true north, the view itself has the setting for its orientation. If that's set to true north, but then what the process, the workflow involves rotating the CAD file into a project north position so that when you acquire coordinates, it gets the true north rotation from doing that. So the solution is to create a separate site plan view that's like a working site plan view that is used, like I literally duplicate the existing site plan view and name it site plan for reloading survey. And then that's the site plan view that I link the CAD into. And I always, before linking the civil survey DWG file, I set the view orientation for that site plan for reloading survey. That view, I set it to project north, so that when I link in the CAD and rotate it into a project north position and acquire coordinates, I don't really know why, other than that for the workflow to work, the view has to be set to project north when you acquire coordinates. And that's how it gets the true north rotation. But then if you change that view orientation back to a true north orientation, when you reload the link, that's when it flips around. So we basically have to keep this working view always oriented to project north and always go to this view if you need to reload the link. And then you would use the other site plan, the main one, that is set to true north. That would be the one that you would put like in your construction document set. That would be the one that would go on the sheet. And this file or this view would be just a working view just for reloading the civil survey. Okay, so I don't think I played the video. I'll play the video because this demonstrates how when the view orientation is set to project north and we reload the CAD civil survey link, it stays in the correct position. It doesn't rotate. So you can see there it stayed. Okay, so this is the workflow for the question that you asked about, Dara, about what happens when the architecture model has not been established intentionally with the corner of the building being at the Revit internal origin. And the process involves when you go to set up your Revit site model file, you have to link in the architecture model first so that you have that building outline there as your reference for moving and rotating the CAD civil link into position. So you should bring in your Revit file origin to origin. So the architecture Revit into the site Revit origin to origin. So that way you know that the origins of both files are in the same location. And then link in the DWG file and go through the same process. But instead of using the origin or the survey point or project base point as the point that you snap to, instead just take the corner of the building from the civil survey and align it with the corner of your building model where you have it modeled. So this video shows that. So you can see the building elements are modeled over there on the right. You can see they're far away from the survey point and project base point. So we just have to find a corner of the building in the civil DWG survey and then move it to that same corner of the building model where you have it modeled. And then once we get it there, then rotate it also into the same rotation. Okay, so we also have this problem very frequently. I dare say it's probably on every single project, where because the civil survey information of the site is drawn so far away from 0, 0, and also sometimes the sites are just so large that the AutoCAD extents is more than 20 miles. And this causes all kinds of problems in Revit. And you guys have probably seen this warning. You've probably seen it so many times that you don't even pay attention to it anymore. But what really caught my eye when I did pay attention to it when I was preparing for this presentation is the words here that say may reduce reliability and result in undesirable graphic behavior. Yeah, that shouldn't say may, that should say does. It does reduce reliability and it does result in undesirable graphic behavior. An example of that is shown here. This is what I have termed the technical term of jagged lines. So this shows the same exact file. Gerardo, you should recognize this because this is what we were working on this morning. The AutoCAD file is on the left. You can see all of these lines are nice and straight and every little indentation is perfect, but we bring it into Revit and this is what it looks like. So this is challenging when we're talking about a process where we're trying to identify and locate and snap to a very specific point of the corner of a building and make it and align it in the CAD or the Cville CAD file and aligning that to what we have in Revit. So when the lines look like this on the screen, when we bring it into Revit, it makes that process very challenging. And here's a video of what it's like trying to snap to one of those lines. And you can see when you zoom in and out how those lines start jumping around and changing. So not only it makes it really hard to try to snap to the lines, it also makes it really hard to tell what you're seeing on the screen. So when we try to move that CAD file and we try to snap to an endpoint, you can see where that pink square snap is, and it's indicating that line just below it. So the line below it was getting highlighted, but the snap point for it was like far away from it. So it's like what you're seeing on the screen isn't reality, but Revit still knows what reality is. So you have to just blindly trust that whatever Revit is snapping to is actually the right point. So what do we do? Like, what's the solution to this problem? Because we can't move the geometry far away from, or sorry, close to 0, 0. That would solve the jagged lines problem, but then we wouldn't have the real world coordinates anymore. So what I've found is I usually end up going into the visibility graphic overrides and turning off as many layers from the AutoCAD link as possible. So the only line work I see is the building outline. So that helps when you're having this weird snapping thing happen where you're having to trust that Revit is snapping to the correct point, even though you can't tell because you can't see it on your screen. Just through eliminating the number of lines that it possibly could be snapping to, it helps a little. So if the only lines that you keep visible from the CAD link are the building outline, then you'll be able to snap to them or have more confidence that the line you're snapping to is the correct line. And also I just use that SE shortcut for the Revit object snap for endpoint and just trust that Revit is picking the right point. But then after I have acquired coordinates, at that point, if you're in a situation where you really need the line work from the Cville survey to be like part of your construction documents and you don't want them to be all jagged lines, once we've acquired coordinates from that file, we don't need it to be far away from 0, 0 anymore. So at that point, it would be okay to open the file in AutoCAD and move it closer to the AutoCAD origin 0, 0. And what I found is we've already identified the point that we want to be our, coinciding project-based point, survey point origin, that point at the corner of the building. So if we move all of the CAD line work from that point as the base point to 0, 0 in AutoCAD, then when we go to link this AutoCAD file back into Revit, we can use positioning origin to origin because the AutoCAD origin is 0, 0. And if we when we moved everything, if we took the point that we want to be our origin or that we set to be our origin in Revit and use that point to put at the AutoCAD 0, 0 origin, then we'll be able to link the AutoCAD DWG file back into Revit using origin to origin, and then our lines won't be all jagged. And hopefully, once you do that, you'll see that we picked the right endpoint when we located it, because we were kind of guessing before when we were just trusting that Revit's snap was correct. So then I thought I would also go through some other considerations and some other things that happen when we're going through this process. So when you're in Revit, after you have acquired coordinates, when you hit save, to save your Revit file, you're also going to get this additional pop-up message telling you that the location position changed for the DWG file because we moved it after we linked it in. And the way that we should answer this question is we should say do not save. We should always say do not save, because if we hit save, what it actually is doing is it's saving back to the CAD file the position where you moved it to in Revit. And that's actually not, like, I don't know, it's not useful. And I think it has caused problems, and there's no reason to do it. And most of the time, if we're going to get an updated file from, if we get an updated file from the civil engineer or whatever CAD file it's asking this question about, it's going to overwrite any save changes we make back to it anyway. The other error message that I've seen happen frequently is this one about differing coordinate systems. So and let's go back to the example of Sal, you have your structural model and you have acquired coordinates from the architecture model. And the architecture model has acquired coordinates from the civil survey. So they are still positioned using the same real world coordinates, but they were acquired from different files. So if we linked in, like if you linked in, actually it'd be okay. Actually, it would be okay in the situation that I just explained. But if, let's see, if we had our separate site file and one of the Revit files acquired the coordinates from the architecture model and one of them acquired the coordinates from the site file, or one from the survey and one from the AutoCAD Revit file, then when we went to link them into one another using positioning shared coordinates, it would give us this warning because it wouldn't recognize that they were actually the same shared coordinate system because it was acquired from two different files. But it's okay. This is just a warning. So when you hit close, it lets you proceed anyway, and then everything still gets positioned in the right spot when you choose auto shared by shared coordinates, because they really are still the same world coordinate system. They were just acquired from two different files. The other thing to take into consideration is when you are exporting your Revit file back out to a DWG file so that you can give it back to the civil engineer to link into their file in Civil 3D. This is a setting under the export. When you go to the Revit command to export to AutoCAD, if you choose the setup options and look at this units and coordinates tab, there's this option down at the bottom for coordinate system basis, and by default it's project internal. So what that means is if project internal was the option chosen, the AutoCAD file that would get generated out of Revit would have the AutoCAD 00 at the location of our project base point. And so it would be using our project coordinate system. So it would basically be 0 at that spot. But if we set it to shared, instead it will make the AutoCAD 00 super far away and make all of our AutoCAD line work of where our stuff is modeled be far away from 00 in its real world location. So that's the option you want to choose, because I've many times heard civil engineers complain they always have to move the architecture model into the right spot. It never goes in the right spot. Well, if we set up our coordinates correctly by acquiring coordinates from their file, and then when we go to export DWG out of our Revit file to give back to them, if we choose this option of shared, then it should work for them. When they go to link our file into theirs, they should just be able to do 00, like origin to origin, and it'll go in the right spot. Okay, and Matthew Kavanaugh, if he's still on the call, this is Spotlight from Stantec. They use this pie piece method, where they've made a family that there's one little piece of the pie for each discipline. And when they all get linked together correctly, it makes a pie. So that's a nice visual to help make sure that all the positioning is correct between all these models from different disciplines. Another thing to take into consideration is there are often small projects that don't have a civil survey. And that doesn't mean that you can't set real world coordinates. If you know what the real world coordinates are, which you could get from a couple different sources, even Google Earth, and you can use the command to just specify the coordinates at the point, the known point, which would be the same point, the corner of your building, the Revit internal origin, project base point, survey point, and you would just specify the coordinates at that point and type in what the real world coordinates are. So you don't have to have a civil survey to acquire coordinates from. You can type them in manually as well. And then my last slide, this is my last slide, is just saying that there may be newer and or more advanced ways of doing what I've just described. This is just what I've found is kind of the most simple, straightforward way that I've tried to make it so that we have the least amount of problems. But I have seen some posts and some webcasts from Autodesk about working with BIM 360 and how there may be a process of linking Civil 3D files into Revit, within the BIM 360 interface, and maybe there's some kind of magic in there that makes the process easier. I don't know. I was going to try to watch the webcast before this presentation, but I didn't have time. So I don't know. It's still a mystery, but I just want to, or it's a mystery to me. I just want to throw it out there that there definitely could be other ways than what I just showed tonight. And another example of that is that within Civil 3D, I know they have an option to export another different file type, which I'm not sure what the file type is, but it will export just the 3D topography. And it's a special file type that Revit can then import directly, but it's just for the topography. And as far as I know, I don't think you can acquire real world coordinates from that. So, but it still might help you get the topography, and it also might help us get other 3D modeled site elements in addition to the topography, which could be helpful. So those are all things for future exploration and future learning. So that's what I have for my presentation. Do you guys have any questions?
I do. That was great. Thank you for doing this whole presentation. It was really insightful.
Oh, good.
One of the last things you posted was about small projects. And one of the challenges that I find myself in a lot is that an architect will create a model just from the internal origin for a small project where you don't need a civil plan. But for me, I need at least the elevation because I'm doing footings and I'm doing smart tags that give the bottom of footing elevation. And it's usually, we'll have usually have a previous, or like the original documents of it where we know what the finished floor elevation is at least. Is there any way that I can set just the elevation of the survey point and coordinate it with the architect, or is it too far in at that point?
No, I think you could, and you do have a choice at that point. You could set it yourself, and then you would know that it was different in your file than it was in their file. And so what that would mean is you would not be able to use shared coordinates to link your file or link their file into your file, and you would need to tell them that they can't use shared coordinates when they link your file into their model. But they could still use project base point, and they could still use origin to origin as long as those points were coinciding in the same place in both files. Or you could even coordinate it with them and say, I'd like to set the elevation, at least if we can. Can you guys set your survey point elevation to whatever it should be? And also make sure they do it unclipped, because otherwise the survey point would still be at 0, but I'm trying to remember how that would work. If you specify, or maybe it would work. I don't know. What I would do is I would experiment with it and set the coordinates of the survey point and just make sure it stays located at the origin in elevation, even though you set it to a certain coordinate. And there's 2 methods you could use to do that. You could either click on the survey point and type in the coordinates, which, whether it's clipped or unclipped, it will behave differently in those 2 scenarios. Actually, it might not let you change it if it's clipped. I think that's what will happen.
Right. So I think, so if I'm understanding correctly, you would, if I wanted to change the elevation, I would unclip the survey point, type in the correct sea level elevation for the first floor, then reclip it. And then the architect will have to match me, or maybe acquire coordinates for me somehow, or
I wouldn't use acquire coordinates at that point. I would
Okay.
just have them do the exact same steps that you did in your model, so that their survey point was still located at the origin in elevation, but had the real world elevation set. And then they could still use survey or shared coordinates for positioning when they link your model into theirs, and you could still use it when you link their model into your model.
Sounds good. Thank you. I'll try it.
You're welcome.
I have a quick question.
Okay.
This goes all the way back to the beginning, but when the whole issue with the proxy graphics, the message that pops up, is that exclusively, like, that's telling you that it was a Civil 3D issue? Like, it's not, I mean, because I feel like I get it every time. And so I don't know, are there other types of files that would cause that?
Yes.
Like, I've gotten it for, like, when I want to import window details from the manufacturer, and
Yep.
And so.
Yeah. Yes. Yeah. The answer to the question is yes. So Autodesk, back in the day, they made just plain old AutoCAD, but in the late 90s, they started to make special versions of AutoCAD for all the different disciplines. So there's an architecture version, there is an MEP version, I think, and a structure version, I think. And so, like, when we all buy AutoCAD, and usually it comes with both AutoCAD and AutoCAD architecture for us anyway. And I think there's a bunch of other flavors of AutoCAD too that are all just part of that AEC collection, and you can choose which one you want to install. But what I think is not well documented and not well communicated is that each of those special flavors of AutoCAD, even though the file format is still a DWG, it's a DWG for all of these different flavors of AutoCAD. It's actually not the same file format. So if you try to open a DWG that was created in Civil 3D or in AutoCAD architecture or AutoCAD structure, MEP, any of these other special versions of AutoCAD, that DWG file, if opened in regular AutoCAD, you're going to get this warning, because each of those special versions of AutoCAD have additional elements in them that you can create. So I'll just use the AutoCAD architecture as an example because I'm more familiar with that one, but in that one, you can generate walls that are actually walls and windows and doors. And those are elements that are in there that you can select and have properties and all of that. And so what happens is when you open that file in regular AutoCAD, regular AutoCAD doesn't know how to understand those elements. So with Civil, I tried to look this up because I didn't know what the special elements were that Civil 3D had. This is what they look like, and they're called like corridors and connections and intersections and all these things that I don't really understand, but I'm sure that civil engineers do. But those are the special elements that if you were to open this in Civil 3D and clicked on those red elements or this like road looking thing, it actually, under properties, it would say what its element type is, and it would say connection or intersection or whatever. And if we were in AutoCAD architecture, we would click on that element and it would say it's a wall, it's a door. And so the problem is that when regular AutoCAD opens that file, it doesn't understand what those elements are. And so that's why we get the proxy graphics warning, because it's saying, I see this element in this file, I don't know what it is, so I'm going to put in a proxy. A proxy is like a substitution. It's just a plain box, really, because that's what this question is asking. Do you want to show the proxy graphics or not? So if you don't show the proxy graphics, you're just not going to see those elements. They're still going to be there. They're still going to slow you down, but you just won't be able to see them. If you choose the option to show the proxy graphics, it will show them, but you won't be able to manipulate them or do anything with them. Or you can show the bounding box, which is just, it'll just put in this like mass thing in the place of that element. But again, AutoCAD doesn't know what to do with them. And then if you link that file into Revit, Revit really doesn't know what to do. And it slows down Revit significantly. It causes all kinds of graphic problems. And so the only solution is to do the export to AutoCAD. And it has to be done within the native program that the file was created in. So that when they do that export to AutoCAD, it's literally taking all of those special elements and it's just converting them into plain old AutoCAD elements that regular AutoCAD can understand. Simple lines, arcs, and circles.
Yeah. Okay.
So it's like almost exploding those special elements down into. But I think one of the areas of confusion or one of the misconceptions is that you can just explode all those elements and solve the problem, and that it doesn't actually work. So like if you get a file from a civil engineer, or like you're saying, these manufacturer files, and you get this proxy warning, you don't really have any way of fixing it yourself. Even if you explode it, even if you flatten it, even if you purge it. I mean, there was a day when I used to try to clean up these files myself, and it never worked. And I would spend hours and hours and hours. Actually, I shouldn't say it never worked. There was a time when it worked, but something has changed recently with the files that are coming from the newer versions of these programs. And for the last 6 months or so, there were a few times when I tried to go through the workflow that I used to go through. And the test is always, you do all the cleanup, you save out the AutoCAD file, and then you reopen it in AutoCAD. And if you don't get the proxy warning, then they're not there, that you've cleaned them up. But over the last 6 months, I haven't been able to do that. So I think something has changed with the software. And the only way to do it is to go back to them and ask them to do an export. Two other things just popped into my mind. One is that you also have to be really careful, because in AutoCAD, there is a setting. It's a command where you can set it to be on or off, to where it will show this proxy warning or not. So you can actually turn it off. So this is bad, because there could be a drawing that you may open that actually has proxy elements in it, but you won't get this warning if the proxy, I think it's called proxy. Does anybody have AutoCAD open right now and can check this? But the command, it's like proxy notification or proxy notify or something like that. You type that into your command line, and the setting is either 1 or 0, on or off. You want to make sure it's on, because otherwise you won't get the warning that there's proxy elements. So that was one thing I wanted to mention. And then the other thing I wanted to mention is, in the situation where a file is coming from a product manufacturer and you're getting this warning from that, like what options you might have. You could try to delete out all of the elements manually that are created from the other program. So hopefully those elements aren't actually needed. So what I often will do is I'll select everything in an AutoCAD file, and I'll use Quick Select to get the list of all the element types that are part of that selection. And then once I see that list of all the element types, often they will be listed like AutoCAD proxy, or sometimes there will even be elements in there that you'll be able to recognize them as not being typical plain AutoCAD. So like points are often bad, so I always delete points because we don't really need them. I'm sure with a Google search, you could search for like, what are the elements that are real AutoCAD elements, that regular AutoCAD understands, and what are the element types that are from these special programs, and you could just try to manually delete them all out of the file, hoping that there will be still enough regular line work to get what you need. Because that's the other thing, is most of the time, for the purposes of what we need, we don't even need any of the special 3D geometry of this element that they have created with the special software. We usually just need the line work anyway.
Yeah. Okay. Yeah, that's good to know. I was curious about that. Thank you.
You're welcome. Any other questions? All right, I'm going to stop sharing my screen, and I'm also going to stop recording. If I can do that. Stop recording.